Okay. Yesterday, we introduced the integral test for the convergence of series. How to use the integral test to determine if a series is converge or diverge. Okay. So the integral test, just do a little bit review. Basically, the integral test will have two things to check. Okay, first define a function. Okay, first define a function n equals 1 to infinity an. So first we'll define fn equals an. Okay, then we need to check two things. F is positive, and second, f is decreasing for x bigger than or equal to 1. When you check those two, then the series n from 1 to infinity an and from 1 to infinity fx dx both converge or diverge at the same time. If the integral diverge, then the series diverge. If the integral converge, then the series converge. That's what we did yesterday. Okay. So today we're going to continue with the second one is P series and harmonic series. Okay. P series and harmonic series. So we're going to look at a series of the form n from 1 to infinity 1 over n to power p. When we look at a form of 1 over n to power p, this is what equals n equals 1, so it's 1 to power p 1. N equals 2 is 2p 1. N equals 3 is 3 to power p 1. Okay. We continue, n equals n is n to power p 1 over n to power p. Then continue, plus to infinity. 1 over infinity to power p. Okay, this series is called a P series. We call it P series. Okay, where p is a positive constant. Makes sense, right? Is a p is constant. Constant p. Example, a special example. If p equals 1, we got this will be n equals 1 to infinity 1 over n to power 1. So just 1 over n. When p equals 1, is n equals 1 to infinity 1 over n. Can anyone tell me if you remember this one? Does this series converge or diverge? Can anyone tell me?
Converge.
Converge? Why is this series converge?
Because 1 over infinity is 0.
Well, 1 over n, that's nth term test. N goes to infinity, 1 over n equals 0. This means the nth term equals 0. Does it give you the series converge? The nth term test will not guarantee the series converge. Series and sequence are different. Sequence is 1 by 1 is one term. A1, A2, A3, A4, AN. But a series is add everything together. Even 1 over n itself, the nth term goes to 0. It does not mean necessarily this whole series will converge. Does that make sense, Lacey?
Yeah.
Yeah, the nth term test can tell you if it diverge, if the nth term not equal 0, it diverge for sure. But if the nth term test equals 0, it does not mean the series converge. Okay, I think I've mentioned that several times. Just remember that. You can use the nth term test to test initial tests. If it diverge, then you are done. If the nth term equals 0, you're not done yet. You have to continue to use other techniques to say if it converge or not. So, is this one diverge or converge? Does this one converge or diverge?
Diverge.
Diverge. Why does this one diverge? Why does this one diverge?
I think if we use the integral test.
Yes.
Then
Very good. Very good, Lacey. Yes. Yesterday we did exactly the same problem. I just want to know if you understand it or if you still remember it. We used the integral test yesterday. Fx equals 1 over x. You change the n into x. And then f is positive. Fx is decreasing. We did that yesterday. You take the derivative is negative 1 over x squared. So it's decreasing. This is kind of like a repeated thing, okay? And then you take it from 1 to infinity, 1 over x dx, which is no matter n goes to infinity, b goes to infinity, ln b minus ln 1. So it's ln x plug in. So it's infinity. So it diverge. So that series diverge. So let's give this one diverge. Okay. Well, this is special. I just want to check here. This is the series when p equals 1, the series of 1, n from 1 to infinity, 1 over n. This has a special name. This equals 1 plus 1 half, plus 1/3, plus continue, plus 1 over n, plus continue. This is called harmonic series. Okay. Okay, the P series. Let me just use a different color to write on this. The P series, n from 1 to infinity, 1 over n to power p equals 1 over 1 to power p plus 1 to 2 to p plus 1 over 3 to power p plus continue plus 1 over n to power p continue. This series first converge if p is bigger than 1. Okay? And diverge if p is bigger than 0, less than equal to 1, they diverge. This is the P series theorem. Well, what do we do today? What do we cover today? Okay. So if the power is bigger than 1, it converge. If the power is less than equal to 1, it diverge. Okay. So, why do we have this? Let's check it out. Let's check what happened, okay? So, what do we have? First, we prove it, okay? We'll prove why it's like that. Let's just check n from 1 to infinity, 1 over n to power p, okay? Use integral test to check this one. When p is bigger than 1. Can you use the integral test to do this one?
get n to 1 minus p over.
Okay. So I'll give you 2 minutes to finish this integral test. See if you can finish that. Say the convergence or divergence of this series. Use integral test. Okay, so are you done? Right. So first, since I said if we use the integral test to determine if this diverge or converge, p bigger than 1, we have that fx equals 1 over x power p. You always change the n into x. Okay, then this is a continuous function. Because our previous one is not continuous, it's just add 1 by 1. Now it's continuous function. So fx is, because x is bigger than equal to 1, then the derivative, then fx is positive, the derivative is negative. We check those two first. Then we take the antiderivative from 1 to infinity, take an integral from 1 to infinity, 1 over xp. So 1 over xp, you can change it to x to negative p power. So now p is not equal 1, p is bigger than 1. I would like a student to tell me here what is the integral, what is the antiderivative of this one?
X to the power 1 minus p over 1.
X to the power 1 minus p. Basically, you would add 1 on the power. So negative p plus 1, so it's 1 minus p. Okay, add 1 on the power. Divided by the new power, which is 1 minus p. It's the same thing when you do have x squared dx, you get x cubed divided by 3. Right? So you add 1 on the power, divided by the new power. So that's the rule for the polynomial function. Okay, for this one, and then we have something is an infinity thing here. You can check that as b goes to infinity and 1 and b. If p is bigger than 1, if p is bigger than 1, 1 minus p is negative. Does it make sense, everyone? If p is bigger than 1, if p is bigger than 1, then 1 minus p is negative. So we plug infinity into here. What is infinity to a negative power? Can you tell me?
0.
0, very good. Then I plug 1 into here. So 1 as x, and 1 as x, at 1 to 1 minus p, 1 to anything is 1. So it's still 1 on the top. And plug 1 into here is 1 minus p. So the answer is just the 1 over p minus 1. This is a finite number. So I prove that if p is bigger than 1, then this integral converge. Therefore, n equals 1 to infinity, 1 over n to the power p converges. Okay, so what if just do all of them together. What if p is less than equal, well, we don't equal 1. Equal 1 have already done yet. We just did equal 1 for the harmonic series. What if it's less than 1, bigger than 0? So we still have everything is the same because it's still xp, right? Everything will be exactly the same, but we just look at the last step. Limit b goes to infinity, x to the power 1 minus p, 1 minus p, and 1 to b. So now, if p is less than 1, what happened? Can anyone tell me?
Divergent.
It diverges. Why does it diverge?
Because we're going to get a positive number for the power of x if we subtract that power from 1.
Yeah, very good. Thank you, Lacey. Very good. So if p is less than 1, 1 minus p will be positive. So you're going to get, if you plug infinity into here, p goes to infinity. So the infinity to a positive power. Infinity squared 1/2, infinity to a 1/3 power. Infinity to a positive power, it will give you infinity. So the whole thing will go to infinity. Okay, infinity goes to the positive power is infinity. Infinity goes to negative power is 0. So that's the part. Okay, now if this one, then it goes to infinity, so then the series n equals 1 to infinity, 1 to n to the power p diverge. That makes sense, right? You use the integral test to prove that for the p series, if the p is bigger than 1, it converge. If p is less than or equal to 1, it diverge. Okay, let's look at more examples. N from 1 to infinity, 3 to the power n, 5 over 3, 5 to 3. Okay. So here, Can anyone tell me what this P is? Maybe I ask a student. Thea, could you please tell me what P is? 5/3, perfect. And then I compare this one with? Thea, can you continue? Bigger than 1, less than 1? Bigger than 1, perfect. If it's bigger than 1, the P series, that's perfect. P series bigger than 1, then the series converges. Perfect. That's it. Okay. So if in the test you have, maybe in this test I don't have P series, but if you have, anytime you just say P series, P equals 5/3 bigger than 1, it converges. It converges. Then that's it. Okay. You do not have to use the integral test to prove it again, but you have to say this is a P series and the P is bigger than 1, so it converges. Okay. That's pretty simple, right, everyone? More example. May call student help me with that. 1/n to 1/5. Okay. Taylor, could you please help me with this one?
Well, the P is going to be less than 1.
If-
1/5 is less than 1.
Okay. So this one, this series,
Convert.
converge?
Yep.
Less than 1 it converge?
Oh, it diverges.
Oh, it diverges, right. It diverges. Okay. You think about this. Sometimes you don't know if it converge or diverge. You can compare that 1 to n squared and the 1 to n 1/2. Obviously, this one is less than this one. So this one is more likely to converge, right? You just forgot. We sometimes get confused. But it's not really hard to memorize to get it. So you can compare 1/2 square. 1/2 square compare with 1/2 to 1/2. Obviously, this one is less than this one. Yes, you can just these way have helped you to memorize. P is bigger than 1, it converge. P is less than 1, it diverge. The smaller one always have a more potential to converge. Right? Okay, so number 3. May Constantine help me in this one. Bella, could you please help me in this one? Yep.
P is 0.95.
Is 0.95.
Less than 1.
Less than 1. So,
It diverges.
so it's P series. It diverges. Perfect. That's simple, everyone? Good? Alright, so let's look at the next one. How about this one? Okay, the difference is that this one you have 2 P series, right? With the previous one. Now my question is, does this one converge or diverge? Make a guess.
Converge.
Converge. Very good. Why do you think it converges?
Because we get like 2 finite numbers, and if we subtract them, we're going to get a finite number.
Very good. Since these 2 series will converge to a finite number, you have 2 finite numbers subtract, add together, it's still a finite number, so it converges. Perfect. So what do? We can separate these 2 as 1/n squared minus n to 1 infinity 1/n to cube. Okay. So since both n from infinity 1 over n squared and n from 1 to infinity 1 n cubed are p series with p is bigger than 1, because for this one p is 2, for the other one p is 3, so p is bigger than 1, so both converge. Therefore, n from 1 to infinity 1 over n squared minus n from 1 to infinity 1 over n cubed, this one converges. Okay. Alright. I'll do another one. N from 2 to infinity ln n. I'll ask a student to help me with this one. What do you think this would be? Nicholas? What do you think of this one? Do you think this one converge or diverge?
I don't know what P is for sure.
Well, this is just any sequence, not just a P series. You can use any of what we learned so far.
Okay.
So what have we learned so far? We learned geometric series, integral test, nth term test.
Could we use nth term?
Yes. Okay. So what is the nth term?
So it's the limit of a of n as n goes to infinity is not equal to 0. Then
Okay.
it will diverge.
Very good. It diverged. Perfect. You did a very good job. Yes. So the nth term, n goes to infinity an, limit n goes to infinity ln n, and n goes to infinity is not equal 0, so this diverge. Okay. Sometimes it's just that simple. The reason I pick up this one, so whenever you see a series, we do P series, we did a lot. Then I give you another one and say what that is. So you can use the previous one, you can determine, okay, this one diverged because the nth term test, FL's nth term test. Alright. So, next one. From n to 2 to infinity, 1 times n square root of n squared minus 1. Can anyone tell me what do you think? Does this one converge or diverge? So what do you think? Does this one diverge or converge? Anyone? So we've already got an nth power, n to first power. Make sense? And there's n square here. It's n square and take a square root. And it's also another first power. We just look at the highest power of this series. Okay, look at the highest power. It's first power multiply another first power. The minus 1 really does not change anything, a constant. So if you compare this with 1 over n times another n, they're very similar, right? You have a constant eventually, it's not really matter that much. So from here, later we're going to explain comparison test. but these two almost like have exactly the same power. Okay, so since this one converge, this one also converges. Okay, that makes sense, right? This is n square. This is 1 over n square. Okay. Alright, so next one, n from 1 to infinity 5 times 1/2 to power n. I'm going to ask a student here. Zijian, could you please tell me this one? Does it converge or diverge? What do you think? Zijian? Not sure? Converge? Okay, why does this one converge? Why does this one converge? Nth term? Nth term not getting. Okay, I want to see one more time. Nth term test will not guarantee convergence. If you use nth term test, you can never get. If you say I use nth term test because then I think this converge. No, you cannot. You can never use nth term test to guarantee the convergence of the series. Okay, you can use nth term test to test if it diverge. You cannot use the nth term test to test if it converge. Does it make sense again? Just one more time. Never use nth term test to determine if the series converge. Okay, if the nth term test you give a 0, give you nth term is 0, you don't know. We don't know if it converge or diverge. But if the nth term test not equal 0, it diverge for sure. All right. So, can you tell me why do you think this one converges? Anyone? Anyone else? Why do you think this one converges? Yep. Go ahead.
It converges to a over 1 minus r because the r is less than 1, I think.
Okay, this is a geometric series. Okay, whenever you say n equals 1 to infinity a times rn, this is a geometric series. Very good, Lacey, thank you very much. Is r less than 1? My bad. Is r is 1/2 less than 1? This is a geometric series. It converges to 1, so it converges to a over 1 minus r. Okay, so this one converges. All right. So next one, n from 2 to infinity 1n ln n 3. Okay, can you determine if this one converge or diverge? I'll give you 2 minutes to work on this one. You tell me the answer. Give you a little bit hint, use integral test. Okay, use integral test. Okay, are you done? Okay, so you can continue. I'll write down the answer. You can compare with what I wrote. Okay. So I have a question here. Did you all get this so far? Or have you finished there? First, you set up the fx equals 1 over x ln x to cube. And then this is positive for all x bigger than or equal to. That's not a problem because x is positive, the whole thing is positive. Then you take the derivative on this one. You can use the quotient rule, or you use product rule. Anyway, you can prove that the derivative with quotient rule is the u over v is v squared over u prime v minus uv prime. U prime is one derivative of 1 is 0, so it's 0 minus the derivative of this one. So it's a negative. You have a negative in front of it. The derivative of this, you get this is positive, the whole thing is positive, but with the negative sign it's negative. So the first derivative is negative, is decreasing. Okay. Then what we have is we take the antiderivative form from 2 to 1 of x ln x cubed. I have a question here. I want a student tell me if you know what do you think we need to continue. Okay, I'm going to ask a student here, okay? Luke, could you please tell me how did you continue from here?
We could do u substitution.
Use
to get the integral.
Okay. U equals what?
Equals ln x.
ln x. Very good. So what to continue?
Then du equals 1 over x. And you get 1 over u cubed du as the integral, plugging that back in, which is 1 over ln x cubed. Or what, sorry, then you gotta do the raise the power, and divide by it.
Right. So, what you got for here? Oh, so you got this one. You got u to what?
We'll do the u to the -2 divided by 2 divided by -2.
Okay. All right. So then plug b as infinity into here. What you got?
If b goes to infinity, you get 0.
Okay. This one.
And then you have -1 over 2 ln2.
You don't have the. What about the square?
Oh yeah.
Okay, perfect. There's a negative here, so it's positive. Then anyway, we got this whole thing. It will. This whole integral. We can get this whole integral. Converge or diverge. Got this one. It converge, right? It goes to a finite number, so it converges. So our series in the end, we got our series n to n from 2 to infinity 1 over n ln cube. This one converges. Okay. So far we've learned nth term test. You can use nth term test to see if it diverges. Okay, see if it's diverge, see if the series diverges. Then we use geometric series. If it's geometric series, use the ratio. And then we learned integral test, then p series. Okay, for the series convergence or divergence. All right. So I think I've assigned a lot of homework for you to do. Okay. So let me ask you another one. How about this one? Does this one converge or diverge? Converge or diverge?
Would this one converge?
This one converge to what? Why does this one converge?
I was thinking because the 1 is going to be the constant in there.
So is that 1 is going to be constant there? This one? Okay. So my question is, if you see this is not p series, right? And it's not a geometric series, right? If I give you this one here at this moment, what do you think you want to do first? Lacey, you have something to say?
I think we can carry the n term.
Yeah. If it's not geometric series, it's not p series. Right now we only have several things: geometric series, p series, and the integral test. This one I cannot do the. I think we can do the integral test, but you have x The problem is if you do the integral test, you have 1 plus x and to x power. If you have just x power, that's okay. If you just have 1 over x, it's okay. But if you have power n, then this one is not much or is not very okay on that integral. So we use the nth term test. See what we got. My question is, what is the n goes to infinity 1 plus 1 over n to power n? 1.
1.
I want to ask another student. Anyone I have not taught yet? Jasper not here? Probably Jasper is not here, right? Eric is not here. I forgot the name. So, can anyone tell me if you don't think this is 1? 1 plus 1 over n to power n, n goes to infinity. Is there any other different answers?
I think the limit would go to infinity.
Okay, there's another answer, infinity. Any other different answer?
Is it E?
Who said E? I don't say that. I don't see very clear. Okay, E is very good. It's very impressive answer. You still remember this? Yes, it is E. Very good. Okay, n goes to infinity. Thank you very much. This is a very impressive answer because sometimes you forgot. We did this example like maybe 3 weeks ago, and 1 plus 1 over n to power n equals E. How you do that? You have to do let y equals 1 plus n over n to power n. Then you take ln on both sides. Ln y equals n ln 1 plus 1 over n. Okay, then you go n goes to infinity, limit n goes to infinity, and you change that into ln 1 plus 1 over n over 1 over n. Then you take the derivative. In the end, you got this one equals 1. L'Hopital's rule. Then you got a y equals e to power y equals e. So that's what we did before. And now if I do this one here, the nth term equals e, and this not equal 0. So the series and from infinity 1 plus 1 over n to power n, this one will diverge. Okay, because the nth term goes to e. Okay, so it diverge. Alright, so that's all for today. Tomorrow we're going to review for the test, and I think tomorrow is Thursday, right? Yeah. So Friday we're going to have our second exam, and you finish if you have not yet finished your chapter 8 quiz, okay, and do several practice of the chapter 9, nth term test, the geometric series, especially those two. Okay, thank you very much. I'll see you tomorrow.